In this problem, we're told a 1.6 meter tall person lifts a 1.95 kilogram book off of the ground, so it's 2.2 meters above the ground. What is the potential energy of the book relative to A, the ground, and B, the top of the person's head? C, how is the work done by the person related to the answers in parts A and B? So the first thing we should do here is just draw an image of what's going on. So imagine this right here is going to be our person, and they're going to be lifting this book up. So here's our person, and so we know they're going to be lifting the book off the ground. So it's 2.2 meters above the ground. So this distance right here, we know is going to be 2.2 meters. So you can imagine this is the starting position of our book, and then it's going to be lifted up here. And so we know that the person's going to be 1.6 meters tall. So 1.6 meters tall. And then we also know the mass of the book, I'm just going to say M in this case, is equal to 1.95 kilograms. So that's going to be that. So let's go ahead and start with the first part. So we're trying to find the potential energy of the book relative to A, the ground. So A is going to be the ground. So how do we calculate potential energy? So you calculate potential energy using this formula. So P sub E, which is just potential energy, is equal to mass times gravity times height. And so the height is going to be the distance that it travels. So the first part is going to be from the ground. So if we want to calculate it with respect to the ground, let's just plug in our values. So we know the mass is going to be 1.95 kilograms. So 1.95 times g, which is gravity. And we know gravity is just 9.8 meters per second. And then in this case, the height is going to be from the ground, right? So he lifts it up from the ground here up 2.2 meters. So the change in the height is going to be 2.2 meters. So the height is 2.2. So if you go ahead and do this, you're going to get 42.042. And so this is going to be about 42. And then we measure it in joules. So 42 joules, that's going to be your answer to A. Now let's do B. So B is going to be from the top of the person's head. So instead of starting here, essentially we're just imagining it starts here. And so my image doesn't look that good, but imagine it starts at 1.6 meters and then goes up to 2.2. So just think about it that way. So if we calculate it, P sub E equals the mass, which doesn't change. It's still 1.95. And then this is going to be equal to 9.8 gravity, right? We're just using this formula. But in this question, the height's going to be a bit different, right? It's going to be this difference right here because we're moving it up this amount, which is just 2.2 minus 1.6, right? So that's going to be that height. So we can just plug that in here, 2.2 minus 1.6, right? So if we go ahead and calculate this, or if you go ahead and do this, you're going to get it equals 11.466. And I'm going to round it to just 11. So 11, or I'm actually going to round it to 11.47. You can round it however you want. So 11.47 joules. This right here is going to be your answer to B. Now for C, they're asking, how is the work done by the person related to the answers in parts A and B? So if you went ahead and calculated the work for this, I'm not going to go ahead and do it because you focused that for last lesson or the last chapter. But essentially you would get it's 42 joules. And so essentially it's going to be the same as your answer to A. And so they just want you to realize that what they want you to realize is that in part A, the potential energy is calculated relative to the starting location of like the application of the force on the book. But this is not the same case in B, right? Because we get a different answer because it's starting from a different place. But yeah, they just wanted you to realize that. So for C, there's not really an answer, but they just wanted you to realize the way it worked, right? The difference between the work and where you start. But yeah, so this right here are going to be your answers, and hopefully you found this video useful.